Hello learners, welcome to TryWrite. Today we'll be learning about Lambda function interfaces and watching the examples as well, so as to found a profound knowledge about all these Lambda functions. Here in Java program, with explanations, you can learn with this explanation you can learn the topic Lambda functions and functional programming, covering both introduction to Lambda functions and functional interfaces. Yeah, coming on to this here, we can see a functional interface plus lambda basics here in this example. So coming to this, there is a functional interface here. This is a functional interface by the name of greetings, and here the main public static void main method line. This is the main method line, and following that we have the lambda expressions here, lambda expressions, and finally combining the functional interface and the lambda expression, we are founding an output here. Yeah. So here in this example, we can see that greeting is a functional greeting. Greeting. It is a functional interface. It is a functional interface. This greeting is a functional interface with an abstract method say hello. With an abstract method say hello. Yeah. And we implement it using lambda expression. We implement this using lambda expression here. Yeah. And this avoids using anonymous classes or cleaner and more readable codes. This provides more cleanable classes, more cleaner and readable code, and using anonymous classes. Yeah. So here we get to see that a lambda function is using the functional interface. And coming here, we have seen that functional interface is one that contains only one abstract method. Has only one abstract method. Say hello, and the at the rate of greet functional interface. At the rate of greet, at the rate of functional interfaces, Annotation tells the compiler that this interface is indeed to be functional. This interface is showing that this indeed is a functional. That this functional interface is indeed to be a functional because this is a functional interface and it contains just one method. Say hello is the one method, that is say hello. Yeah, here only. Here it is containing only one method, say hello. Using it, making it perfect for use with a lambda expression, making it perfect to use for lambda expression here. Now coming on to the example, we have seen that this is an expression, lambda expression. This is a lambda expression. This is a lambda expression where it matches the method signature say hello. It matches the method signature say hello. Say hello here. Yeah. There are no arguments and no return void. The return type is void only. There is no argument provided here. There is no argument, and the return type is void only. Yeah. No need to write any anonymous class. And much more cleaner and concise. So it is much more cleaner and much more concise also. Now coming here, the key benefits. The key benefits we have seen here, less boilerplates as compared to anonymous classes. There are less boilerplates as compared to anonymous classes. It emphasizes how lambda expressions work seamlessly with functional interface. It emphasizes how lambda expressions work seamlessly with functional interfaces and improves code readability and maintainability. Here there are functional interfaces. Here there is a functional interface which is having a one method, say hello. Functional interface by the name of greeting, having say hello as only one method. Here coming to the main method line. Here we can see that there is a lambda expression. This lambda expression is founding an output based on the system on its body part, founding an output system.println say hello, hello lambda, and finally greet is a name we are assigning to this function, and say hello is the method. Greet this one is greet. This lambda expression shows that this greeting is named by the name of greet. So greet dot say hello. So finally here we can see, here we are using the lambda expression to implement the greeting interface. Here we are using lambda expression to implement the greeting interface, single abstract method say hello. Say, since it's a functional interface, you can skip creating you can skip creating a whole class or anonymous inner class and directly provide a method logic using lambda expressions. When we run the program, it says hello lambda, the controller, demonstrating the simplicity and power of functional programming in Java. So coming here, we have the greet. Greet is a greet comes from the greeting by this greet is of the greeting type, and this method will return a value coming to its body part. Coming to its body part, it will return a value. Now, this greet by the name of the greet, you can call this method by the name of the greetings. This greet is of type greeting. By this help of this greet, you can call the method that is in the greeting class only. Greeting interface only. Greeting interface is having a method. You can call this method. So coming here, we have the output say hello, hello lambda. Now moving on to the next part, we have the lambda with parameters. Here we can see we have a lambda expression. Here we can see that we have a lambda expression here. Yeah, we have a lambda with parameters. So this is a function. This at the beginning at the rate of functional interface. This is a functional interface by the name of interface adder. Adder. Yeah, which have the int method, which has a method add, and has two parameters int a and int b. Add method is having two parameters int a and int b. Now this is the main class. Lambda example2. Lambda example2 is a class here, which has a public static void main as a main method line, and here we are here we have the lambda expression. And the body part says that system.out.println sum plus sum dot add 5 and 3 are the values passed to these parameters. Now this lambda a and b, a plus b defines the method add, a plus b define the lambda expression with the help of lambda expression. This a plus b, a comma b, and finally giving a plus b. This defines the method add. The lambda expression can take parameters and return values. No need to simplify the type int. We don't need to simplify this type int. Java infers from the interface. Interface. Now coming to this, we have seen that this surface has one abstract method. Add. One abstract method is there, add a and b with parameters a and b int a and int b, which takes two parameters and returns an integer value and returns an integer type. Yeah, because this has a returning type also, integer type. Yeah, and again marked with functional interface. Again, it has the functional interface as the marked functional interface to enforce that it has only one abstract method. Now coming on further, we can see that this lambda expression with parameters, lambda expression has two parameters a and b as the parameters, and the expression a plus b returns automatically. A plus b is returned automatically, and for a return keyword, the return keyword or braces, because it is one line. Yeah, this is equivalent to yeah, this is equivalent to a adder sum. This is equivalent to adder sum. We are seeing that adder sum, this value is this sum is of the type adder. Is of the type adder, having two parameters a and b. When they are passed, they will perform the addition of a and b. When they are passed, they perform the addition of a and b. And finally the value will be returning sum. Message sum plus sum method name dot the function name. Add. Method name dot the function name. Interface name having the parameters 5 and 3. And finally this method will be added. By the as this method when we will pass 5 and 3, 503 goes here as parameters, and the final body part coming to the addition of both. Final body part coming to the addition of both the parameters pass here. So finally, we see that lambda expression can expect parameters and return values, and cleaner syntax. It is a cleaner syntax without without needing anonymous classes, and perfect for short stateless and implementations of function. And perfect, we can see that it is perfect for short stateless implementations for functional interface. So finally, we see that this example shows a lambda expression that takes two parameters a and b and return their sum. The adder interface defines the method int a and b, int a and int b, and the lambda directly provides it with logic a b, giving the body part as a plus b, giving the body part as a plus b, and then we can call sum.add. Then we can call sum.add with parameters 5 and 3. It prints as sum 8. It will be giving output as sum 8, and this is a powerful way. So we can see that this is a powerful way by which we can do simple operations without cluttering the code with extra classes. Without cluttering the code with extra classes. Now coming further, yeah, we have the lambda with block body and return statement. We have the lambda with block body and return statement. Here we have the first line as at the rate of functional interface annotations, and which has the interface by the name of string concat, having the method as string, which is the returning type of the method, and the combine is the name of the method with parameters string a and string b, It has a class lambda example tree. It has a class lambda example tree. Now, which has the main method line public static void main string args, and coming to the lambda expression, there is a lambda expression string concat concat sc, which is this is, so we can say that this sc is of the type string concat, and here the body part, here the parameters when passed will return to a body part as string result a plus and b. Here coming here, it has the body part as string result, this is a body part which has a result which will be returning the addition of a and b, and concatenating the addition of a and b. Now return result. Now we have the return result to uppercase. Whatever the value will be there, all the value will be returned in uppercase. Here we have the functions. We have the string part. There is string part. In the string part, we have the whatever the things that are written in the that will convert to uppercase, and finally we'll print the value of these. Finally will be system.out printed, and finally for printing of these values, we have to call this function method sc dot combine combine. Sc is the name of that we are performing the operation. This sc of a string cat as named as sc dot method name dot function name. Function name here is combine here. Combine method name. Combine is a method name here. This is a function name. Sc is the function name. So string sc is a variable name. Sorry, it's a variable name. String sc is a variable, and here for the variable sc, we have the method as sc to combine. Combine is a method which is have the coffee and code. So finally we can see the output as capital letter coffee and capital letter in the uppercase coffee and uppercase code as found here according to the lambda expressions and the our own values what we want to add and perform. Yeah. So coming here, we can see that it's a multi-line lambda. It's a multi-line lambda with curly braces and return statement, and demonstrate that we can see that it's a multi-line lambda in the curly braces. It's a multi-line lambda in the curly braces and return statement and a return statement. Yeah. return statement is there. Yeah, and return statement is there, return by the name of return. Return statement is there by the name of return. Yeah. It demonstrates that lambda can have complex logic inside a block. Lambda can have complex logic inside a block. It's good for cases where the logic is more than one line. It's good for cases where the logic is more than one line. Now coming here, we have seen that interfaces has one method. String if combine interfaces that have interface has one method. Yeah, interface has one method. Combine parameters string A and string B that returns a string. As returning type is string only. Since it has one abstract method, it's valid to use for with a lambda. Since it has only one abstract method, it is valid to use with lambda. So we can use lambda here also. Now the parameters A and B. The parameters A and B are of string type. The parameter A and B, string A and string B. They are having a string type. Inside the lambda, first it concatenates the string and inside the lambda, lambda has the body part. Within the curly braces. So inside the lambda, we have to concat A and B. A is being concatenated with B. B is being concatenated with B and this AND sign and with this AND sign. Now then it converts the result to uppercase. Then it converts finally this result will be as stored here and this result will be then converted to result dot to uppercase. Finally this result will be converted to uppercase and use of this curly braces use of this curly braces and a return statement this return statement and the return statement is required here because the body has multiple statements. This body has multiple statements where we are first using lambda expressions and then we are returning the values. So these lambda expressions with two parameters. So this is here we are seeing the lambda expressions with two parameters and multi-line lambda body with intermediate variables and logic and return values beyond simple calculations. Returns values that is beyond the simple calculations and using a string method inside lambda logic. So finally we have seen here that here we have a functional interface string concat with method combine that makes the two strings. The lambda expression implements it by combining the two string with ampersand and ampersand in between and then converts the result into uppercase. Since we are using more than one operations inside the lambda, since we are using more than one method inside lambda, we wrap the body into curly braces and use the return statement and when we call sc dot combine coffee and code, we get the value coffee and code. We are getting output as coffee and code in uppercase. This shows that lambda has a handle multi-line logic, but not just a single expression. Here, the single expression is not there. It's not only the single expression is there, but multi-line body is there with converting the result to the uppercase. Now coming further, we are here in this example. Lambda is lambda in a list of for each lambda dot for each for functional programming itself. Here we have to import this from java.util.arrays. First we have to import this package java.util.arrays and import java.util.list. Yeah, because we are using list. Yeah. Now it demonstrates how lambda will work with functional APIs for each. It demonstrates how lambda works with functional APIs like for each. More readable and concise than traditional for loops. And core idea is functional programming. Apply functions to data collections. Now coming here, we have a class. We have a class lambda example form, which has a main method line, and there is a list of generic types. Generic type is string. Generic type is string. The list is generic type is string, and the name of the list is names. And the arrays as list. We have to giving the values as Alice, Bob, and Charlie. Now the list is consisting of the three values: Alice, Bob, and Charlie. Here we are using names for each. Names dot for each. This is a list of for each. This is a list of for each, where the names will be given names will be given to the body part as function store or println hi plus the name, and this value when it will passed when it is given, it will return similar values, similar return output, on the console. So coming here, we can see that for each is a default method in the iterable interface introducing Java 8, and it makes the lambda expression or method references for an argument. And here the lambda name, name is given to the system of println hi plus the name is executed for each statement in the list. Each statement is here. Each statement will be for each statement. This value will perform for each statement in the string. For Alice separately, for Bob separately, and Charlie separately. So coming here, you can see the output as hi Alice, hi plus the name, hi the list hi the list name as Alice, hi plus Alice. Then coming to the next part, it will be again repeating the same thing, and hi plus Bob, and then again coming to the last part, writing hi plus Charlie. So the key concept here is lambda expression is a single parameter, that is name. Here we are seeing the lambda expression with a single parameter, that is the name, and no need to here name, lambda expression with a single parameter name, and no need for traditional for or while loop, because we are using for each loop directly here, and use lambda to make iterations more expressive and readable. It is making the lambda for more expressive and readable. Now coming here, we can finally watch out the working for this code. You can see that here there is a list of names, list by the names, list by the names having generic type of string, and having the list of all the three names. Right? It is a list of three names. For each name, for the different names, for each name, this things will be printed. I plus the name, I plus name will be printed. Lambda expression following to the output, following to the body part as system printed, and I plus the name in the list. So output will be hi Alice, hi Bob, and hi Charlie. So we have seen that in the example we have a list of names. Using the for each method. We apply a lambda expression to the each element. Lambda takes a single parameter. Each name is in the list and prints a personalized greeting. This is a simple yet powerful demonstration of how Java supports functional style operations on collections using lambdas. Now coming further, we have the example of using lambda with comparator. Yeah. So here in this example, we have to import this java.util.arrays. We have to import this package. Then we will import java.util.list this package, and then finally we will be importing this java.util.collection package also. For this, we have the class as lambda example file, which has the main method line, and here we have a list which has generic type as string, and fruits by the name of fruits. There is a list by the name of fruits. Here it has the different names provided here. Fruit name as in banana, apple, and mango. And we have to sort this list using lambda. For collections.sort, Here we'll be using collections dot sort. Here we have the collections of the different fruits, collections of different fruits, which we will be sorting by collection dot sort, and the fruits the names, the list of the names fruits a comma b. This is the lambda expression. This is the lambda expression, which is having a output as a compared to ignore case of b. When a is compared to ignore case of b, and finally printing an output system.println fruits. Finally printing the output of system.println fruits. Here here comparator this comparator. Yeah. Here comparator with generic type st is built in function is used as functional interface. Is built as functional interface. Here we have a functional interface. Yeah, with functional interface, and lambda makes sorting logic compact and expressive, and it emphasizes the real world applications of lambda. It emphasizes the real world application of lambdas. Now coming here, we can now coming to this part of the questions. We have seen the array. We have seen arrays.asList creates a fixed size list of two claims. Creates a fixed size arrays as list is create a fixed size list of two claims, and collections to sort collections dot sort is used to sort the list, and it takes the list to sort, and lambda expression acting as comparator, and lambda expression acting as comparator. This lambda expression is acting as comparator. The lambda expression AB, when it will be giving a dot compared to ignore case B, it will compare two strings ignoring the cases. It will compare the two strings ignoring the cases. Yeah. Now coming further, we have seen, and now coming further, here we are having the list. Here we are having the list of the names. Output will be as a list of names only, for fruits name only, which we are providing in the list only. This apple, mango, and banana. So here the ignoring the cases. Here first A will coming first. A is less than B, then B will be coming at the second, and M is greater than C. So M will be coming at the last. Now we have seen that here we have seen that in this example we sort a list of fruits using lambda expression. Normally sorting with a custom rule which require creating a comparator. Will require creating comparator class or anonymous class. But here the lambda expression AB. Here the lambda expression AB. This lambda expression AB compare A dot compared to ignore case B. A dot ignore case B gives a case sensitive comparator in a single line. If this will give us case sensitive comparator in a single line, and this shows how lambda expressions with single code which makes code simpler. This shows how lambda expressions will make our code simpler, shorter, and more readable when working with collections. So finally we can see the output as apple, banana, and mango here. For the provided list is banana, apple, and mango. Now coming to the end, we end this class. We'll meet up in the next class. Thanks.